Hey guys, Jason here. This is a little bit of a different opening. I'm adding this in after the fact because I feel like while I was going through stuff in this video, I maybe wasn't quite explaining some things that I wanted to explain. So I just want to mention this isn't so much of a tutorial as it is showing kind of what I've experimented with, the results of it, and I do still show everything that I did and explain it. So if you guys want to follow along, you can. It just won't be the kind of thing where I'm typing it as I go. I already have it written. I don't know if you guys will find that more useful or better than when I'm typing it along and making typos and having to fix it and memorize everything that I'm doing prior. If you guys do or don't, I would love the feedback. And there was something else I was going to mention as well, but I'm drawing a blank to it. Probably should have figured that out before starting this, but I just wanted to hit record. I'm throwing this in right before, as you guys can tell. But yeah, I hope that you guys like it. A short while ago, I had been asked if we could use MLAgents with Unity's NavMesh. And I wasn't sure at the time because I was thinking the only experience I've had with NavMesh is using it for basically game AI. Like with the zombie shooter, we used MLAgents for the shooter, sorry. And we used NavMesh for the zombie because I didn't want to have to train a zombie to just walk towards the agent. So I sought out to kind of combine the two in this project. It's not complete. The training needs work, and but I figured it's good enough to showcase them working together. There was another method that I thought of that I think would be better suited for combining MLAgents and NavMesh. I didn't do it here, but essentially I'll explain how I have this set up and then I'll point out where I think the difference would be. So I have a little agent right here. Oops, my fingers are in the wrong spots on the keyboard. Little agent right here. I have a little red dot. I guess it's not really little, but I have a red circle for the quote unquote face, and then a cylinder for the body. Cylinder is just easy because with the NavMesh over here, it's a cylinder already. And so I was like, well, cylinder for a cylinder. And I guess before I jump into all of this, I should, show you guys how to get NavMesh, how to use NavMesh if you don't already know how. If you do, feel free to skip ahead. I also went over it in the zombie shooter one when I implemented NavMesh with the zombies. I went through that, but I can show it real quick. We have to install the NavMesh package, much like the MLAgent package. So you'll go to Window, Package Manager. Make sure you're on Unity Registry. Usually it's in project by default, but you want to go to Registry. You can just type nav, and there will be AI Navigation. You'll hit the Install button here, and then after it installs, there should be a Remove button like I have. If you wanted to install MLAgents and you don't have that set up, well, I would recommend checking out the Pellet Grabber series, the very first episode. First, I don't know how long, like 10 minutes, 15. I'm not really sure. But the very beginning, I go through setting up Unity, Python, and the MLAgents library with all the dependencies. That's the video that I use. Every time I set up one of these projects, I go back and I look at it and I make sure I have everything set up. But if, say you already know all that, you can just, right here, MLAgents, you can install it for Unity if you have everything else set up. And then in order to get this navigation, you'll go to Window, you'll have AI here once you have the NavMesh installed. If you didn't have navigation AI installed, NavMesh, this won't be there. So you do this, and then you select navigation. A little window will pop up here, and you can just drag it over wherever you like. So like how I can drag this over to here. I just have it over here so I can switch between the two. I changed this, it should say humanoid. I changed it to agent, and I messed with some of the settings here just to match what I had here. With that, after doing all of that, then I went and I built the environment. I named it normal NavMesh environment. I have a dynamic one, which let me go ahead and actually disable that right now. We don't want that enabled. I don't have anything built in here. As you can see, I can shrink this. I can see everything. I don't have anything in there yet. Next video will be with the dynamic NavMesh. I think I'll go with a simpler environment than this with that, because this one's a bit more complex for the agent to try to figure out how to work with the NavMesh, which I think is where I was running into issues. I didn't have a simple environment for it to begin learning first, and then gradually make it more complex. But for the environment, I have a target. It's just right here. It's a trigger, collider, just a little box, and then I have a material on it to kind of make it transparent. I like making things transparent or translucent. Right here, goal. I originally had it called goal. I changed it to target. I just made it red, set rendering mode to transparent, and then I made it somewhat transparent. So I can go ahead and change this. So we have the target now, and then before we go to agent and NavAgent, I have spawn points. You can just have one spawn point if you want. I initially had one, and then I was thinking like maybe it'd perform better if I had multiple spawns. It kind of performs about equally as terrible for all of them. But I have these little spawns, same kind of setup. It's just a cube with a color, and inside it is also a trigger, so there's no collision. The agent won't run into it. It'll just go right through it, like as if it doesn't even exist. For the terrain, normally I don't have just a terrain setting, but because we're using NavMesh, I like it because I can just say, hey, do the current object hierarchy, and I have it set to terrain for the NavMesh surface, as you can see. And when I have it set to the hierarchy, it'll just do everything underneath here, which is the plane and the walls. And then the walls is just a bunch of cubes. If I were to remove this, you can see when we go to terrain and we bake, let's say I bake right now, this is saying everywhere is walkable except for this outside edge. If I go ahead and I put the walls back and I bake, now we have a path around these walls. And so that's how I can show you that the agent does respect the NavMesh and follows its rules, because if I get rid of the walls, it will still follow this outline. I can't move it outside of it, which at first I thought it was, until I got rid of the walls and tested and like, oh, okay, it's not. But yeah, so we baked the NavMesh. So when you have a terrain, this is just an empty game object. I go down here, I search for NavMesh, and then I add the NavMesh surface. I select whether I want this surface to be walkable, not walkable jump, or you can make your own if you want. You can see it, I think, over here. Yeah, agent type, or that's agent types, areas. Here we go. You can add other areas. So if you want somewhere where maybe they swim or they fly, you could do that. And yeah, so then I have a walkable terrain now. It takes into consideration everything here, and we bake it. It's as simple as just hitting bake. If you're doing something more complex, then maybe it won't be, especially if you have anything with slopes. Slopes, if we go over here to agent, it can go up a 45-degree angle slope, or if steps, a step height of 0.25. I don't have any of those, so I don't really have to worry about that. But if you do, it can make things a little bit more complex. I'm going to go ahead and show with the heuristics, because the agent's not very well trained. If I hop over behavior parameters, change this to heuristic only, we hit play, you'll be able to see I can move the agent. I'll get rid of the walls, and you can see that it respects the boundaries. So let me go ahead, I'll zoom in a bit. When we go here, it's bumping into the walls. And if I go ahead and I get rid of the walls, it still respects the boundaries. I can't go past these boundaries. I can go slightly over, and then that's it. Which is where I was thinking that it was ignoring it and just bumping into the walls until I got rid of the walls. But if we go around, I'm not very fast with this guy, especially if I don't have the walls to see up here. But we can go all the way over here. The reward is kind of far away. But if I make it all the way over, now I'm guessing, there we go. And it resets, gives us a different spawn. And yeah, we can see we have a little line here going to where the target is. I'll go over that in a moment. I feel like I'm a little scattered on this. I haven't recorded one of these in a little while. I just threw this together. Well, quote unquote, threw this together. It took a few days to get it working as well as it does. But I wanted to make the video now before I started going through the dynamic NavMesh, because I'm going to start changing some scripts and stuff. And I wanted to go through while I knew it. Let's go through setting up the agent. We have a NavMesh agent. It's as simple as just coming down here and adding a NavMesh agent. I didn't really change anything in here except for speed. That's just how fast the agent will move. Angular speed, I believe it'll affect turning, how quickly he turns. At least that's how I have it set up in the code. You could just do speed for both, I suppose, if you set it manually. Then, you know, the normal MLAgent stuff, we have a behavior parameter, vector size of 7 for taking in the location, the target location, and then their movements. A heuristic, just, you know, because we wanted to control it ourselves. If you train it and you have a brain, you can always add it in here. MLAgent controller script. This is the script that I'm using in order to control it, and is, you know, the MLAgent part as well as, I guess, yeah, it's the MLAgent part and the NavMesh part. We have the NavMesh agent. It's set as none because I set it in the script itself, so I don't have to drag it over. Target I set here. I don't set it in the script in case I wanted to change anything. Spawn locations. These ones are set manually. It's these 3. But for the target, I didn't want to have 3 targets showing. I just wanted to have 1 show. So I have manually set 3 positions in the code. Then decision requester and the rigid body. Rigid body was so then that way we could interact with the cube. I didn't want to have to figure out another way, like, you know, taking coordinates or anything like that. I was like, well, if we throw a rigid body on there, we don't do anything with it in the code. It's literally just there for collisions. Let's hop over to the code, and hopefully you guys like this format better than me creating everything for you. I feel like I'm a little more scatterbrained with it right now, but at the same time, I'm hoping maybe it's a bit easier to follow along, so I'm not making a bunch of typos as I try to write stuff and, you know, changing things, and you guys have to watch me type everything, where I can just kind of go through and show what we did, and you can see what it is. And I'm hoping as well that I will have all of this on GitHub, so you guys can access the files if you want that way instead of having to write everything. I'm not going to promise that yet because I need to see if it actually works since when I go to put it on there, but I think that it should, and we should have something in the description. But in the ML Nav Agent controller agent, we have a NavMesh agent, a target, we have a path. This path we will update periodically whenever we want to make sure that we're on track with where the target is. That's what that little line is that we saw going from the agent over. In fact, if I run it, we can see that little line. That's the path that's has been calculated. And it's also what we were seeing in the console here. So we can see the line, but if I go ahead and move, we get the reward going. I had other prints, but I removed those. We have this little line, and it goes around every corner for like the shortest path calculated in order to get to the object, which is where I was thinking another ML agent could, instead of using it to control this agent here, instead have one that kind of just sees the board, either, you know, visually sees it or programmatically sees it, where it's just, it knows the locations of everything, and then maybe it can pick which one is closest, and you can kind of train it to pick the closest one. I didn't do that, but I was thinking that could be another option. But if we were to move here, you can see this line gets updated. So it's not a rigid line. It always draws from the agent to the target. So if we hop back over here, we have this path. We have previous distance to target and current distance. This is I'm using in order to calculate that reward that we saw bottom right based on the distance I only have it set to give a reward if I get closer than the previous distance. If I get further away, there's no reward. I was trying punishments, and I think it was just circling around and around. I think it was just like, oh, you know, maybe I can just rack up points kind of thing. That's where I'm still messing with stuff. You'll see how I have it set up here. We have the spawn locations. It's a list of size 3 because we have 3 spawn locations. We have a list or an array of target spawn locations, and I just have them hard coded here. We have a step count and a max steps. I was doing this in order to give a sort of end condition, like, hey, you weren't going fast enough, because otherwise it could just sit there, or it could just spin in a circle forever and never learn anything, because it never ended in order to collect that the knowledge, the experience, and build on it. So I gave it a step count and a max steps. For the initialization, I just set the NavMesh or the NavAgent for the NavMesh agent instead of dragging it over in the inspector, just doing it here in code. Similar thing like what we would do with a rigid body. On episode begin, I have spawning the agent and I have spawning the target, and then establishing the path. We do path, new path. It will then, between these two, it calculates the latest path in order to get to the target, the best path that it could find given where we are currently. And then I set the step count to 0. So this will be wherever spawn is essentially to the target. And the agent doesn't know this. It doesn't observe this. It will observe the distance, as you'll see when we get to the observations. The distance from the target, it'll know if it's getting closer or further. It doesn't know that it wants to get there though, which is where the issue is with training, is how to get it to want to go there. When we spawn the agent, we have a random index because we want to pick randomly between the 3 areas. It is a range 0 to the count. It counts 3, so index 0 to index 2, because it's not inclusive of the number 3. And then we have the transform random spawn. We're selecting a random index of the spawn locations list. And then we're gonna, for the vector spawn, a random spawn location, we're setting our location for where we want to go. And then we're gonna move ourselves here. And since we're using NavMesh, we're gonna use a warp in order to move the entire agent and a NavMesh to that area. The target, we don't have a NavMesh that we need to worry about, so we can just set the location here, and it's the same kind of logic going on. We have a random index that we find based on the length. This one was also 3, could be longer, could be shorter, depending on what you guys want. When you're, if you're altering this code or if you're writing it right now and you're following along. And for the observations, so here we can see it knows its position, it knows the target's position, and it knows the path. I guess, yeah, or the path distance, I should say, not necessarily the path. It doesn't observe this. We just calculate the path again, but we're not making a new path. We're grabbing whatever the current path is, and then we're getting the path distance, which we'll see down below. The actions that we have, every time we take an action, we want the step count to go up, because we only want so many actions to happen. I might have had the number really short here. I'm still not sure. I'm probably going to mess around with this more after this. I'll probably run it more and get it, maybe a larger step count. It did seem to kind of start making progress once I upped the values for the rewards. So I was getting, I think, like 50 for finding the area, and every once in a while I would find it. I didn't run that for too long to see. But for movement, we have, just like with our zombie shooter and the pellet grabber, we rotate, and then we can move forward and backwards. So it's just turning and forward and backwards. There's no side-to-side movement or diagonal. But it can combine the two. And so we just take the forward position, multiply it by the value that we have here, and then there we go. There's the NavAgent speed and angular speed. So if you wanted to, you can mess with these settings wherever they are. NavMesh, these two settings in order to change the speeds. It kind of turns really slow at 80, so you might want to crank that up a bit. And then I did have this in here, and I was testing to see if it stayed within the bounds without this, because thought I was having issues with it staying in the bounds and then not using warp to move, and instead just editing the transform. I didn't end up needing this, and I didn't realize I left this in. If you want to try this out and see what it does, if it changes anything for you, I'm leaving it here so you can see it. And then when we're going through and we're taking the actions and we're moving, we want to recalculate the path to make sure we're going the correct way, that we're getting either closer or farther. We just want to know. And then down here, I check if the current distance to the target is less than the previous distance. If it is, we're doing great. We're getting closer. So we're going to add a reward based on that distance and multiply it by 1. It does get to be a smaller reward the farther or the closer we get, but it's adding it. It's not setting it, so it's cumulative. So like maybe the first reward is 0.5, then the next, well, I guess not 0.5. We'll just say it's 0.5, and then the next one's 0.4. Well, now you're at 0.9 total. So you're getting a higher reward, and it's only if we got closer. If we're not closer, then there is no reward. And I tried a penalty that I don't think penalties really work. They don't really help. The agent getting less of a reward is already a penalty to it. But if you wanted to mess around with having a penalty, this is where I was putting it. So then that way, if we're getting further away, it's racking up negative points. And then I have the step count. If the step count is greater than the max steps, meaning that we've exceeded how many actions, that's the word I'm looking for, actions. If we've exceeded the number of actions that we want, so let's just end the episode and we'll start the next one, and whatever training, whatever information it got, whatever points it got, it will hopefully use to get a better score next time. Go ahead and minimize this. For heuristics, same setup. We're not shooting or anything or doing jumping or anything fancy. So it's just, we get WASD, the horizontal and vertical movements. Nothing, strange here. It's the same stuff that we've been doing in the last two projects. Very basic. On trigger, enter. This is why we needed the rigid body. This is for when we run into the target, we get a reward. I had a smaller reward here. In fact, on the on action received, I had like 0.1. Oh yeah, I have 0.1 here, which I guess, yeah, I'm printing out the old reward here. I did have 0.1 and I changed it to 1. So like maybe a bigger reward it would like. Not that I guess that really matters, but I don't know, maybe it looked at a bigger number and I was like, oh, yes. I did give it 50 for if it hits. I was like, I want it to be a massive number when it gets to target and be like, hey, I did something really good there. This is much larger than what we had before. I got to do that again. Seemed like it kind of helped, but I need more testing for that. Now, update, get path, and draw gizmo. I guess this one we do use throughout, but the other two mainly are just being used to show the path for us to be able to see it. So in the update, we calculate the path. We do the NavMesh path, new NavMesh. We calculate, and then path distance equals. Oh, actually, sorry. I was using this for a debug in order to see where we were. You don't need any of this right here. I forgot. I commented this out right before we started. Yeah, this is just for. So I could see. Actually, I can show you right now. Is I was having issues with it not calculating a path, or at least I didn't think it was. And actually, yeah, there was a few times it didn't. If I go ahead and let's find the other debugs, so that way you guys, don't have to see them. Control F, debug. We can hide this. And come on, Unity. There we go. It was loading everything. So if we go back in here, I still have control over the agent. We'll be able to see in the console the distance. Target distance is 32. Let me turn around here. And it's getting closer. We're now 20 away. 11, 10. And so you could, instead of having a rigid body, you could just, be like, hey, when this reaches 0 or below 1 or something, we can just say we're there. And so if you wanted to kind of debug the path, you can, go ahead and use this. Let me go back to right here. We're in update. So let me go ahead and hide these. Did I duplicate that? I guess, oh, maybe that's why it wasn't searching. I did Control D, not Control F. We'll go ahead and get rid of this. Hide this. The get path distance. This one we're using in order to, see the distance for the path. So we iterate through the path's corners, and then we add everything. So in here, I guess we can't really see. I've only done a little bit with NavMesh, so I might be slightly wrong here. I would suggest you guys, check out the documentation. I believe it checks the distance to right here, and then from there to there, basically to each incremental point in the navigation. In order to get the full distance, we sum them all together into distance, and then we can just return that value, and we know the entire path distance, like from point A to point B, and then point B to point C to point D, and that's how you know the distance from A to D. And then the onDraw gizmos, that's what's showing the line, so that way we can visualize the path that the agent would take. And if you guys want to see the actual, let me go ahead and actually, I'm going to pause and I'll throw in the brain. I haven't tried the brain yet that I made. I made a lot. I'll be right back and let's try it. Ran into a slight issue getting the brain set up. I'm not entirely sure why, and I figured, I'll just show training instead. So let's say I run this training example. So we can see then the agent, it respects the bounds. It doesn't really understand what the bounds are. It does respect them. Let's just hope this loads quickly since I'm recording as well. While it tries that, let me see, is there anything? No, I went over everything in the code here, and showing the nav agent itself will be quick. Let me pause while it thinks. Oh, no, never mind. There we go. It's going and it looks good. Yeah, I might have it on heuristic. Oh, behavior type. Yeah. Okay, I do have it on inference. Oops. Set the default and go ahead and run this again. We're going to run it as example 2. Let it go ahead and load it a lot faster this time. Maybe because it was I had just opened it. Maybe that's why. First time trying to get everything going. Run this, and we can see it's trying to kind of figure it out. Let me go ahead and hide the walls so we can see it respects the boundaries. Doesn't ever exceed them. And it kind of slowly makes its way in a, backwards. I noticed it likes to go backwards a lot with this, which is kind of weird. And you can see it reset there. It never made it, but the steps were up to 15,000 steps that I had, which if I allowed it to go on longer, maybe it would figure it out faster. Something that, kind of just got to experiment with, see what works. Also, the settings that right now I'm using the default config settings. I didn't change anything. What I was doing before, I went and I just grabbed the config file we used in the zombie shooter, and I changed the name, and I was like, yeah, this works. And it's probably not the smartest idea to do. It's just, I wanted to see if it worked with NavMesh, and it does seem like it does. You can see it's making progress. If let me see, I don't think, we haven't gone far enough for any sort of reward to show up. But let's stop it. We don't need to see this anymore. And let me just show you the difference. So the machine learning agent can eventually learn how to solve the maze, I think, with maybe a bit more help, and also starting with probably a simpler task for it to understand all the values that it's getting. Let's just run it with a normal NavMesh agent. I don't have it resetting when they reach the goal, but it will go to the goal. Look at that. Okay, that was a really easy one. It's just a straight line, but it did go just straight there. Run it again. There we go. Bit more complex. It follows almost perfectly the path. Like it swung out a little wide here. I think because it's just going faster and doesn't turn as quickly as it moves. But yeah, the NavMesh agent, for something like pathfinding, I don't think machine learning is great for it, at least in this kind of environment where we know where we want to go and we can calculate the path. Something like with the pellet grabber or the zombie shooter, yeah, it didn't really know where things were, and so it kind of had to figure it out. You could still, probably with NavMesh and, just using raycast, build something that, would know how to shoot the zombies really quick, only shoot at them, and move around everything in a more simplistic or nice manner. But it's always fun to kind of piece together. But yeah, I just wanted to show the difference between those two. And then next time for the next video, which I'm going to guess this goes up on a Monday, in which case the next one will go up on Friday. If this goes up on Friday, then the next one will go up on Monday. I will have the dynamic NavMesh environment set up. Probably something simpler. Maybe I'll just have the the square set up, and then it's just some things moving back and forth for it to then figure out its way through, and just maybe straight line. That way we can see the agent can actually learn a bit better. But I am curious to see if you guys mess around with this as well, what you come up with. And hopefully my rambling kind of made sense with this. If it did, I'd love to hear that it did. If it didn't, I'm happy to try to answer some questions, and hopefully I don't ramble in those. And with that, I hope to see you all in the next one. See ya.